On this 2011 through 2022 F250 Superduty with the 6.2 gas engine, P0171 may mean the PCM is adding fuel because bank 1 appears lean during fuel control. The truck may have a rough idle, hesitation, low power, or it may just turn the light on with no obvious drivability complaint. Possible fault areas can include unmetered air, vacuum or intake leaks, fuel delivery, purge flow, fuel quality, ethanol learning on flex fuel applications, and sensor or connector problems. The key is to stay calm, preserve what the PCM captured, and work the fuel control path in order. Start with the basic system checks, then look at what codes are present. Do not read the whole fuel control family out loud. Just use the code groups to decide whether this is still the P0171 path or whether a different code needs attention first. For this lean code path, do not clear the DTCs and do not reset KAM yet. Go into the PCM data and record the ECT or ECT1 value from the captured conditions so you can reproduce the operating conditions later. If other unrelated codes are present, check what they mean first. If this is only the fuel control concern, move on to the visual inspection. With the ignition off, make the visual inspection count. Check the air filter and housing for restriction. Look from the MAF sensor to the intake manifold for air leaks, loose intake tube connections, cracked or punctured ducting, damaged hoses, and anything obstructed or restricted. Check the throttle plate for sludge or an obstruction. Then, look over the vacuum hoses and tees, EVAP lines, intake manifold and gasket area, EGR sealing points, PCV system integrity, exhaust leaks at flanges and gaskets, oxygen sensor wiring and pins, and make sure the dipstick tube, and oil fill cap are seated correctly. If you find a non-vacuum concern, repair it as needed, clear the PCM DTCs, and repeat the self-test. If the concern is a vacuum leak, verify that repair with fuel trim before calling it fixed. If the visual inspection does not find the problem, carry out the relative injector flow test with the scan tool routine. If that test is not available on the vehicle, follow the pass side of the decision path. If the test fails, the path supports installing a new fuel injector for the injector in question, then reset CAM, clear the PCM DTCs, and repeat the self-test. Next, carry out the power balance test. Again, if the scan tool test is not available, follow the path side. If the power balance fails, the path supports installing a new fuel injector using the injector type that applies to the vehicle. Then reset CAM, clear the PCM DTCs, and repeat the self-test. If both tests pass, continue to the purge and air leak decisions. Next, check for a purge valve stuck open. Use the scan tool evaporative emissions CPV check if it is available. If it is not, make sure the fuel filler cap is installed or the supplemental refueling adapter is removed. Turn the ignition on, record the FTP voltage PID, start the engine, command EVAP CP to 0%, and command EVAP CV on at 100% duty cycle. The check passes if the CPV check passes, or if FTP voltage stays within 0.5 V of the recorded PID voltage value within 30 seconds after closing the purge valve. If it fails, the path supports installing a new EVAP canister purge valve. Then clear the PCM DTCs and repeat the self-test. If the path sends you through the vacuum leak fuel trim check, start the engine and monitor CHT, ECT, ECT1, IAT, long FT1, short FT1, long FT2, and short FT2. Recreate the concern with coolant temperature between 82 CS to 101 CS, 180 degrees Fahrenheit to 215 Fahrenheit, and with the intake air temperature less than 46 CS, 115 Fahrenheit. Add long trim and short trim for each bank at idle. Then increase the engine speed to 3,500 RPM for 10 seconds, and calculate total correction again at that speed. Fuel trim at idle is more sensitive to a vacuum leak, so the decision is whether the difference between idle and 3,500 RTM is less than 15% of the total value at idle. If it is less than that on this lean path, continue to fuel pressure. If it is not, go locate the vacuum leak. On this 6.2-liter Super Duty lean code path, a passing purge check can send you to the map response check. With the ignition on, record map V. Start the engine and record map V again. If the value changes, continue to fuel pressure testing. If it does not change, pause this path and continue the MAP sensor diagnostic instead of guessing. To locate a vacuum leak, start the engine and watch SHRTFT1 and SHRTFT2. Restrict vacuum lines one at a time for 30 seconds while watching the trim response. Do not clamp or pinch a hard plastic hose. Use a vacuum cap or equivalent. If restricting one hose drops short trim by greater than 15%, follow that leak. If it does not, inspect the intake manifold and intake gaskets for a vacuum leak and repair as needed. When a vacuum leak has been repaired, prove the repair. Start the engine, monitor SHRTFT1 and SHRTFT2, let the engine stabilize at the same temperature needed to recreate the concern, and record the values. Shut it off, repair the leak, restart it, let it stabilize again, and compare the new trim to the original trim. The repair is verified when the decrease in SHRTFT PIDs is greater than 15%. If it does not drop by more than that, a vacuum leak is still present. If the shared path takes you to the UR2 SPC circuit check before fuel pressure, diagnose only the suspect universal oxygen sensor circuit. With the ignition off, disconnect the universal HO2S connector and the PCM connector. Then measure resistance between UO2 SPC pin 1 at the universal HO2S connector and UO2 SPC at the PCM connector. The circuit should be less than 5 ohms. If it is not, repair the open circuit, reset KAM, and repeat the self-test. Before opening the fuel system, remember it may still be pressurized with the engine off. Relieve pressure correctly and follow fuel handling safety precautions. Make sure the universal oxygen sensor connector is connected. Install a mechanical fuel pressure gauge. Pressurize the system. Start the engine and let pressure stabilize. Then shut it off. Restart. Command the fuel pump with the FPPID and run the pump to obtain maximum fuel pressure. The pressure has to be within the correct range for the vehicle being diagnosed, so use the correct vehicle-specific fuel pressure range and do not invent a pass or fail number. If it is not within range, pause this path and continue the fuel pressure diagnostic. If it is within range, check the FRP sensor for bias. With the ignition off, disconnect the fuel injection pump connector. Start the engine, monitor FRP, and command fuel mass DI to maximum. FRP should be between 345 to 827 kPa, 50 to 120 psi. If it is not, the path supports installing a new fuel rail pressure sensor, then clear PCM DTCs and repeat the self-test. If the FRP check in use compares FRP to FLP, the FRP PID should be within 138 kPa 20 psi of the FLP PID value. If it is not, the path supports installing a new fuel rail pressure sensor, then clear PCM DTCs and repeat the self-test. After that, reconnect the fuel injection pump connector and check pressure stability. Run the pump to maximum pressure, command the pump off, allow pressure to stabilize, record it, and monitor the fuel pressure for 10 seconds. The fast leak-down check passes if pressure stays within 34 kPa, 5 psi of the recorded reading after 10 seconds. If it fails, inspect the tank, lines, and filler pipe for an external fuel leak. Repair any leak as needed, then continue into the correct fuel system path and repeat the self-test. If no external leak is found, continue into the leak-down fuel system branch. If the fast check passes, continue to monitor the fuel pressure for 1 minute. The slow leak-down check passes if pressure stays within 34 kPa, 5 psi of the recorded reading on MRFS or greater than 275 kPa, 40 psi on ERFS after 1 minute. If it fails, continue into the leak-down fuel system branch. If the shared path sends you to the electrical noise check, inspect the CKP sensor harness for routing, alterations, incorrect shielding, or interference from other systems. Also check for radio frequency interference and excessive audible generator noise. Repair any concern found, clear the PCM DTCs, and repeat the self-test. If no concern is found, pause and use the unable to duplicate path instead of guessing. For the fuel separation check, use a 200 milliliter beaker and a 25 milliliter graduated cylinder. Put 5 milliliters of clean water in the beaker. Use the pressure relief valve on the mechanical fuel gauge to drain 22 milliliters of fuel into an approved clean container. Pour 20 milliliters of that fuel into the 25 milliliter graduated cylinder, then add enough water to bring the total liquid volume to 24 milliliters. Stopper it, Shake it and let it stand for approximately 3 minutes. The ethanol and water mix settles to the bottom and the gasoline rises to the top. If the fuel does not separate, treat it as contaminated fuel. Replace the contaminated fuel, clear the PCM DTCs, and repeat the self-test. If it separates, record the separation level. To calculate ethanol percentage, subtract the amount of water added, then multiply the new value by 5. As an example, if the separation level is at 14 milliliters, the percentage of ethanol in the fuel is 50%. If no ethanol is present on this P0171 path, continue into the fuel system diagnostic. If ethanol is present and the vehicle is flex fuel, compare FFINF to the calculated ethanol percentage. FFINF should be within 20% of the calculated percentage of ethanol. For example, that may display as between 32 minus 48%. If FFINF is within range, continue into the fuel system diagnostic. If it is not, reset KAM, start the engine, monitor FFLRND, and drive approximately 11.3 kilometers, 7 miles, or until FFLRND indicates yes. Some fueling habits, like only adding small amounts of fuel or repeatedly switching between gasoline and an ethanol blend greater than E15, may keep the PCM from learning ethanol content correctly. Once FFLRND indicates yes, key off and back on, then compare the updated FFINF to the calculated ethanol percentage. The updated value should be within 20% of the calculated percentage of ethanol. If it is within range, return the vehicle and advise correct flex fuel practices, including staying with the same fuel for the next 2 to 3 refuels. If it is not within range, continue into the fuel system branch because something may be preventing the PCM from learning correctly. For a non-flex fuel vehicle, check whether calculated ethanol is less than 25%. If it is, continue into the fuel system diagnostic. If it is not, repair is necessary. Advise the correct fuel type, reset KAM, and repeat the self-test. After the fuel and fuel quality checks, the path comes back to sensor and connector basics. With the ignition off, disconnect the universal HO2S connector and inspect for pinched, shorted, or corroded wiring and pins, oil or water contamination, cross-sensor wires, and a contaminated or damaged sensor. If you find a concern, repair it as needed, clear the PCM DTCs, and repeat the self-test. If there is no concern on this 6.2-liter V8, continue to the universal HO2S activity check. On other applications of the shared path, the MAF functionality check may be used first. Start the engine, monitor RPM, MAF voltage, MAF HZ, and MAF flow. Run the engine up to 1500 RPM for 5 seconds, return to idle, and repeat. The idle value should be within 30% of the normal PID value. If it is not, pause this path and continue the MAF and IAT diagnostic. For the universal HO2S activity check, reconnect the universal HO2S connector. Start the engine, monitor fuel sys, and let the engine enter closed-loop fuel control. Then monitor RPM, EQ-RAT11, and EQ-RAT21. Increase the engine speed to 2000 RPM for 1 second and return to idle. The decision is whether EQ-RAT11 or EQ-RAT21 changes across 1, either from greater than 1 to less than 1, or from less than 1 to greater than 1. If it does change, the concern cannot be duplicated or identified at that time, so pause and use the unable to duplicate path. If it does not change on this P0171 path, move to the final HO2S operation check. If the shared path is being used for a rich condition instead, there is a crankcase fuel leakage check. Start the engine at normal operating temperature. Record long FT1, long FT2, short FT1, and short FT2. Shut the engine off, disconnect the PCV line at the intake manifold, temporarily plug the intake manifold port. Restart, idle at normal operating temperature, and compare trims. If the trims shift and the rich condition is no longer present, that rich branch supports installing a new fuel injection pump, then clearing PCM DTCs and repeating the self-test. If not, it continues to the final HO2S operation check. If the original code check sends you down the oxygen sensor response branch instead of the P0171 lean branch, keep that testing separate and diagnose the suspect sensor circuit. First, run the engine at approximately 2000 RPM for 3 minutes and see whether the same response codes are present. If they are not, pause and use the unable to duplicate path. If they are present, check the HO2S harness for shorts between circuits. With the ignition off, disconnect the PCM connector and the suspect HO2S connector. Then check the sensor signal circuit against SIGRTN, VPWR, and the heater circuit for the suspect bank. The resistances should be greater than 10K ohms. If not, repair the short circuit, clear PCM DTCs, and repeat the self-test. If that passes, check the HO2S circuit for an open by measuring the sensor signal, SIGRTN heater, and VPWR circuits between the HO2S connector and PCM connector. Those resistances should be less than 5 ohms. If not, repair the open circuit, clear PCM DTCs, and repeat the self-test. Next, turn the ignition on and check the HO2S signal circuit for a short to voltage. If voltage is present, repair the short circuit, clear PCM DTCs, and repeat the self-test. If no voltage is present, reconnect the PCM and the suspect HO2S, start the engine, allow the engine to idle for 2 minutes, monitor the oxygen sensor voltage PID, and record it. The voltage should be less than 1.5 volts. If it is, pause and use the unable to duplicate path. If it is not, move to the final HO2S operation check. If the flex fuel learn branch never reaches a learned state, check for correct PCM operation by disconnecting the PCM connectors, inspecting for pushed out pins and corrosion, then reconnecting everything and making sure the connectors seat correctly. Verify whether the concern is still present. If it is still present, that branch supports installing a new powertrain control module. If it is gone, the system is operating correctly at that time, and the concern may have been caused by a loose or corroded connector. For the final HO2S operation check, turn the ignition off, disconnect all PCM connectors, disconnect universal HO2S11 and HO2S21, inspect for pushed out pins and corrosion, reconnect the PCM and HO2S connectors, and make sure they seat correctly. Reset cam, carry out the PCM self-test, and verify whether the concern is still present. If it is still present, the path supports installing a new universal HO2S. Then reset cam, clear PCM DTCs, and repeat the self-test. If it is gone, the system is operating correctly at that time, and the concern may have been caused by a loose or corroded connector. The takeaway for P0171 is simple. Preserve the captured data, prove air leaks and purge faults before moving on. Verify fuel pressure and leak down safely, and check fuel quality before condemning control parts. For more diagnostic training, visit stepdiagnostics.com.